Welcome to 6th lecture in the course Industrial Engineering and Operations Research. Today we will be discussing about the work. So, the topic is work study. Work means any type of work, productive work which will bring profit to organization. Organization can be anything, it may be production industry, it may be service industry. So, we keep doing the work, but we have to study process of doing the work in a very scientific manner. What is the purpose of this talk? We want to make industry more productive by studying the work. So, enhancing productivity through methods and measurement. That means what method of work should be there. Some work can be done by 2-3 methods, which method is optimum, and measurement, how we can measure our performance that we are doing the work at optimum level. These are things we will be discussing. So, work study may be defined as the analysis of a job for the purpose of finding the preferred method of doing it and also determining the standard time to perform it by the preferred or any given method. So, two aspects are there. We have to find out what is the best way of doing something, and the other thing is that we have to find out what is the standard time if we do that type of work. So, work study therefore comprises of two areas of study. One is method study, that is we can also call motion study if in context with the human beings. Actually it is hand movement or something, how the hand should move, how I should keep my eye level and all those type of things. And time study, that means work measurement, how much time something has taken. So, what it achieves? Work study enhances efficiency and productivity in processes. It achieves cost reduction and time savings, and it also improves workplace ergonomics and safety. We will discuss more about ergonomics. Ergonomics is an applied science of how the persons work in industry and they interact, what is the effect of the surroundings on the body or mind of the persons. Okay. So, ergonomics we will be discussing in more detail. So, it improves workplace ergonomics and safety. Now, components of work study. So, two main parts of work study. One is method study. Here the focus is that optimize methods and reduce unnecessary movements. So, many times there we do unnecessary movement. Sometimes even in kitchen, suppose we have kept the items, but these items are not placed in a convenient position. So, therefore, it takes more time to cook a food. That type of thing also comes under the purview of work study, that how the item should be placed, so that my hand can easily reach there. It should not get over stressed, or something should not be very close, so that it is very difficult for me to make proper movement. So, all those type of things will come in the method study. In the second part is the work measurement. By work measurement we can find out standard times for task. How do we know that how much time it should take? How, suppose airline is there, how much time it should take for boarding? They announce boarding at 9:15, you might have seen in 10 minutes they say boarding is complete. Okay. So, that means they know the idea that what is the standard time, how much time for when the plane has landed, from the landing of the plane up to that passenger comes out, how much time it will take. So, naturally there should be some measurement of the time. People might have documented this, or there is a need for document, so that if another airline is taking less time, you are taking more time, you can improve your performance. All that type of things also we will study. So, here let us give some overview about the method study. First part is method study, then we will talk about the work measurement. Method means to simplify processes and improve workflow. In what manner some tasks should be done. So, key steps are: number one, select the process. any process. Say for example, you can say boarding of the passengers in the aircraft. Okay, that may be one process. So how it should be done? You might have seen in the counter some person will be there who will check your boarding pass and all those type of things. Then somebody enters in the register also, or the same person enters in the register. They have made some methodology. So you choose that process, then record all relevant details. That means how the process is being conducted at present. Then analyze the recorded data and then develop a more efficient method. Can there be more efficient method, and implement and maintain the new method? That type of is the objective. So how the data is recorded? So there are some tools, some techniques. One is the flow process chart, where we can show the movement of man, material and machine in industry. String diagrams can be made to visualize movement, that how the movements are taking place, that we can show in terms of string diagrams. And then layout designs for workspace optimization, that is also done. Okay. So we will not go in each and everything in much detail, but we will at least give some glimpse, particularly that how the flow process chart works. Now I am giving the example, a factory assembly line analyzing material flow using a flow process chart. I am giving this flow chart from a practical industry, that where I did some work. So they were making some that some type of cream in a continuous process mode. So there are machines and there is a complete line. Okay, it is a type of chemical plant where they are making some type of cream, okay, to put in the body. Okay, so distance, I have made one column, distance in meter. Then I have made several symbols. These symbols are generally used. Then description of that thing, activity, and then manpower needed. So symbol 1 means this is the first operation. So operation has been denoted by circle. Some standards are there, so it can be this thing like opening of valve manually. Then we have made arrow type of thing, that means transportation. So transportation to this particular machine and manpower needed is 1. Then another thing is that if you have the square outside the circle, so circle means operation, square means inspection. So inspection and operation both are taking place. Filling the spout, somebody is inspecting and somebody is putting. So one operator, one inspector. Then transport by conveyor. Then third is that operation, manually placing in flow that machine. So 3 plus 1 operator. Inspection is square. Okay, so inspection has been shown by square symbol. Then transportation. Then putting in slew and counting, that means operation is also taking place, simultaneously inspection is also taking place. Then transportation. Then after that hand sealing. Then transportation. Then packing. Then packing is operation. So you know how much operator, that is also written. And then storage. Storage has been shown by inverted triangle. This is a symbol. Then finally some inspection. After storage, again the inspection, whether packing everything is okay or not. Similarly, for another process, there can be another flow chart, that pouch filling on machine, the first operation. So one manpower is 1 operator. Then transportation, then line inspection, then collating, that some operation is there. Then slew putting, then transportation. Then master packing in curtains, then transportation, then inverted triangle means storage, then after that inspection. Then this we have said that. Now maybe I can give one more example. Distance in meter symbol, bottle feeding in pucks, transport by conveyor, then filling 1 operator, third capping, inspection, puck unloading and inspection, then labeling, printing, simultaneously some inspection will be there. So 2 inspectors will be seeing that. Transportation, small packing, transportation, then some packing, then transportation, putting slew and shrinking, then again transportation arrow, then again 1 operation, then again transportation, then again auto typing machine operation, then storage. Storage means inverted triangle. Okay. Then another one, automatic filling by machine, one operation. Transportation, another operation. Transportation is shown by arrow. Small carton packing, inspection by square, sleeve putting and packing, then transportation, then master carton packing. So these are the examples of the flow chart. That way we understand the process, that at present how the process is going on. That is the one step about that. So we can make the flow process chart. So what do we do that? If we have seen this flow process chart or other things, we can now move to the other step, that how to optimize the things. Okay. So what are the basic principles? Eliminate unnecessary steps. Okay, you see that maybe that step may not be needed. Combine tasks where possible. Suppose you know that two operations same man can do efficiently, so you have to do that way, and rearrange steps for efficiency. Steps can be rearranged and simplify procedures. There is a lot of savings by eliminating redundant steps in a process. Redundant means unnecessary steps in a process, they can be eliminated. So tools used in method study, that means standardized symbols for recording task. Then naturally that we also do time and motion studies for detailed analysis. For that we use stopwatch to measure task duration, or nowadays you can in your mobile phone also there is a stopwatch, by that you can do the measurement. So before we talk to the time study, which is the other part of that, one is the method study, what is the correct method and how much time it is taking. That one was propagated by earlier by Frank B. Gilbert and his wife Lillian Gilbert. So Frank B. Gilbert and Lillian Gilbert. Okay. Frank B. Gilbert was born in 1868 and he died in 1924, whereas Lillian Gilbert was 10 years younger to Frank B. Gilbert and she died in 1972. Both have contributed a lot to time and motion study and also in industrial engineering in general. So little bit we will tell about them so as to make the background, and then after that we will move ahead. So Frank Gilbert and Lillian Gilbert formed the famous innovative husband-wife team that revolutionized modern industrial engineering. They have immense contribution in shaping up industrial engineering to its modern stage. The couple followed in the footsteps of F.W. Taylor, Frederick W. Taylor. He gave the same Taylor who is famous for giving Taylor's two-life equation. He is in a way called father of scientific management. That means he studies how people work, what method can be applied to motivate them. These type of things he did, and he wrote the book on the scientific management. That's why he is called father of scientific management. So these two couples, that means Gilbert and Gilbert, they actually followed Taylor in the philosophy. So they gave concrete shapes to Taylor's concept of time study in performing a work. So the Gilberts primarily followed the steps of identification, analysis and measurement of basic sequences or motions involved in completing a work. So they analyzed each and every motion. Frank and Lillian Gilbert firmly believed that there could be only one best and the most efficient way of doing the work. They conducted extensive studies on the method of doing a work regarding sequence of operations, time needed and idle motion and time. In fact, they applied these methods in their home also to do work in the optimum way. So they were pioneers in using motion pictures for motion study and analysis of work and the workers. Now Frank Gilbert was the first to propose that a nurse should help a surgeon by passing surgical instruments to reduce time and unwanted motion during surgery. So he made that process of surgery more efficient, otherwise doctor will face difficulty. So in what location nurse should stand, what type of instruments she should supply, those type of things he contributed. He introduced various improved technique for reducing unwanted motion in the activities of the army and bricklaying methods. When we make a building or wall, then bricks are laid, how the worker should give brick to that main mason and how it should be done properly, all those type of things they did it. Thus, the Gilbreths introduced time and motion study to identify the most productive and the most efficient methods of executing a work. So, they did both basically. When we say time and motion, that means we are studying method also. Suppose we just say time study, that means time measurement like a machine, but motion study, how the motion is taking place, and they found the most productive work. The Gilbreths tried to implement their rule, one best way of doing a work for higher efficiency in their household activities also. That means there is only one best way to do something properly. Their other innovative contributions towards scientific management are mass production, then human factors and ergonomics. They are related, and sometimes human factors engineering and ergonomics is used in synonymous way. And psychology, industrial psychology also they contributed, both of them, and it had revolutionary effect on industrial engineering productivity and management practice in industry. So, Lillian Gilbreth was the first industrial psychologist to integrate psychology with industrial management and obtained a PhD degree on psychology of management in 1914. Okay. So, Lillian Gilbreth obtained the PhD in 1914 on industrial psychology. The concept of industrial management by considering the personal need of the workers, interpersonal relationship and differences was initiated by Lillian Gilbreth. Her management techniques were very successful for improving productivity in an industry. She planted the seeds of the human relation movement that emerged subsequently in the 1930s. That means many people started working in industrial engineering about human relation movement. That means how the human should be more efficient, more productive, and they should face less fatigue. So, Frank Gilbreth and Lillian Gilbreth are immortalized in the classic books Cheaper by the Dozen. That means their books are there. One book is Cheaper by the Dozen, that means which tells something importance of the mass production, that if you purchase something in dozen, then it will be cheaper. And Bells on Their Toes, authored by two of the Gilbreth's children as a tribute to their parents. So, they actually published basically Gilbreth's sons, children, they got it published, okay, encompassing the ideas of that Frank Gilbreth and Lillian Gilbreth. So, they also are famous for giving that some symbols for the movements etc., body movements etc. So, in their honor they are called thalbricks. Gilbreth is there, you just reverse the word. So, this becomes, its reverse becomes thalbrick. Okay. In reverse order it is called thalbricks. So, thalbricks will contain what, like suppose you are searching something. So, this is the symbol for that. Transport loaded, this is the symbol. Inspect means this is the symbol. Rest for overcoming the fatigue, that is this symbol. Find, this symbol. Position, this symbol. Preposition, unavoidable delay, this type of system. Avoidable delay, this type of system. Assembly, this type of system. Grasp, this type of thing. Use, this type of system. Plan, this system. Hold, this type of system. Disassemble, this type of system. So, we have given here many symbols here, 4 to 6, 4 10, 4 14, 4 18, 18 symbols I have discussed here. So, mostly that they were given by Gilbreths and they are used actually this one. Okay. Now, coming to the work measurement. Okay. So, one is the method study, other is the measurement. So, purpose is to establish standard times for task. Importance is that capacity planning, you can understand how much is the capacity, then you can do cost estimation, then you can do fair workload distribution, these type of things can be done. Depending on if you can measure the work, you can understand that this process will take that much time, accordingly you can discuss. So, techniques of work measurement are of course time study, only we just do that time study, measurement of the time. Other is predetermined motion time systems. Okay, if we have this particular, it is something like micro type of method. If you know this particular thing takes this much time, each and every motion, and some work is having 5 motions, so the time for 5 motions can be added and you can find out. If you have the database, then those type of things can be done theoretically also, or in computer you can calculate that doing this type of task will take how much time, because you will have idea that how many motions will be required. And third thing is the work sampling. Here we do some type of random study, and based on that we get the idea that how much time it will be taking place. So, we will tell more detail about work sampling in subsequent lecture, but here we focus little bit on time study part. So, time study procedure is that select task to measure. First you select a task, then break tasks into elements. That task is comprised of say 5-6 elements, then measure each element multiple times, then apply some performance ratings, because you are doing a time study on a person who may be very efficient, his performance rating may be 2. Okay, compared to normal person's performance rating is 1, his is 2. So, naturally he will do work much faster. So, you have to compensate for that. So, that is why you have to apply performance ratings, and you have to add allowances for delays and fatigue, because when you are observing, then that time the worker is doing full time, he is not going to bathroom etc., he is just devoting sitting with you, but in practice he will go to bathroom etc. also. So, that time also has to be added. So, example of calculation, suppose you observe that it takes 4 minutes to do a task by the worker. In 4 minutes the worker has done that job, okay, but his performance rating is 110%. That means he is not 100% efficient like a normal man, rather it is 110% efficiency. So, therefore, his rating becomes 1.1, divide by 100, 1.1, and suppose you give allowance 10% of the total time, you can give allowance also, so that you easily you can calculate. So, you can say standard time is equal to observed time into rating. You observed some time and apply the rating, and you add some allowance in that, then it becomes standard time. So, I observed 4 minutes, but I will multiply by 1.1. That means we will think a normal man will take maybe 4.4 minutes. On top of that, I write some allowance also. Now, types of allowances, why we do give the allowances? That means personal needs. Okay, any type of this thing, somebody takes he has to take medicine after every 1 hour, he has to drink water. Then fatigue, they get tired, they need some rest. Unavoidable delays, some unavoidable delays may also take place each day. So, I give one numerical example. Suppose I observe time is 5 and let us say rating is also 1. Allowance is 15%. So, therefore, standard time here becomes 5 plus 5 into 0.5. Now, you have to be careful that usually sometimes I have given the allowance of 15% unobserved time, but people may say that in standard time, total time it has to be given that allowance. Okay. So, that can also be made, that suppose you can say something, if I have to give on the total amount, then we have to give that thing. Suppose we say standard time is S, so it would have been not 5 into 0.15, S into 0.15, then S will, you can take to other side with a minus sign, and then you can find out what is the standard time. That can also be done. Say for example, if standard time, observed time is 5 minutes and performance rating is 1, so 5 into 1, it is not, but you say S into 0.15 and is equal to S, that means standard time. So, therefore, S becomes 0.85 divided by 5, and therefore, S will become 5 divided by 0.85. Okay. So, this value may be slightly different from that what it has been done. Okay. So, most of the books generally they follow this type of procedure. They give the allowance on the standard time, not the normal time. This much is called the normal time. This is normal time. Okay. 5 into 1 is the normal time. If rating was 2, then 5 into 2, 10 would have been the normal time. Okay. So, this is just measurement of the time study, and let me tell you that in many times worker unions etc. may oppose the time study also. They may say that why you are doing time study, and workers also become psychologically insecure type person. So, that is why in many industries time study is done with reluctance. They try to avoid that. But another method is there. If you do not want to do time study, you go to work sampling. Here what do you do? Observing random samples to estimate proportions of time spent on activities. Procedure means again defined activity categories. Suppose something that worker is working or not, take random observations and calculate activity proportions. Say numerical example, like suppose I just random way, I observed a person 100 times, I made a random visit to that person, and 60 times I found that he was working and busy. So, that means 60 were productivity. So, productivity means 60%. So, that means it is something that he is 60% time he is working and other time he is not working. So, like that. So, now practical applications that you know of this one, see method study etc. how it helps that also we will discuss. Improving material handling in a manufacturing unit by optimizing transport routes using method study. So, before it took 5 steps totaling 10 minutes, and after we applied the method study, then it took only 3 steps because redundant steps were removed and it totaled only 6 minutes. So, savings was 40% reduction in time. So, now I will finish this lecture with one example of the basically calculating the standard time. Suppose a teacher has set a question paper and asked 5 students to solve it. Time taken by the students and their corresponding CPIs are given in the table. They are cumulative performance index is known to us. Assign a performance rating in the following manner. If suppose CPI is 9 to 10, that means he is very bright, is to give the performance rating 1.5, and if the CPI is between 5 to 6, that means the student is weak, give the performance rating 0.6, and in between you can give a performance rating in a linear way. CPI range 6 to 9, in that range you can give in linear fashion. So, like that you do, and providing 10% allowance on the standard time. Find out the standard time to solve the question paper for each student, and what is average standard time and 95% confidence interval. So, here we are telling that suppose these 5 students, Rahul's CPI was 9.27. So, therefore, naturally that we time taken was 120, another one 8.6 time taken is this, and like that I have given the table. Now, how to solve this problem? First you find out the performance rating. Suppose 9.27, that means 1.5. If it is 8.6, then by interpolation I find out the performance rating 1.38. If it is 5.4, that by then we got 0.6. Like that we have made the performance rating. Then we calculate the, actually they took 120 minutes, but you for a normal person you have to multiply it by performance rating. So, 120 into 1.5 will be 180. That means normal man will take 180. Why Rahul could do in 120 minutes? Because he was 1.5 times performance rating man. So, that is it becomes 180. Similarly, Rahul Singh will take 140 into that performance rating this much, and Reyansh actually took 180 minutes. But since his performance rating is also poor, he is a poor person, so the normal man will take 180 into 0.6, that means 108. And then standard time, because you have to give 10% allowance, so by that formula 180 divided by 0.9, that means 200. So, you see that in automatically 200 into 0.1 is how much? 20. So, that is why normal time becomes 180. and here. So, like that I calculated the standard time, then I can find out average standard time by this one. So, that means average person will take 176.67 minutes, and standard deviation of the standard times I can find out. That means average is 176.67. So each value is standard values, I should subtract this one. Here is standard is 200. So 176.67 minus 200 whole square plus 176.67 minus 214.67 whole square. Like that I do and divide by n minus 1, that means 5 observations. So 4 minus 1 4. We have to use for small samples n minus 1 formula. So divide it not by 5 by 4, and you do that, you got a standard deviation 46.89, too high standard deviation. So we want to know that for the degree of freedom, if 5 observations are there, degree of freedom is 4. So and I want to take 95% confidence level. So I can apply T distribution for calculating the limit, and in the T tables are given. I just have taken a portion of that table. Here 95% confidence means alpha is equal to 0.05. Okay, 1 minus 0.95 is 0.05, and degree of freedom is 4. So T value is 2.776. So upper limit of the time will be mean value 176.67 plus 2 T value multiplied by standard time and divided by under root 5. Okay, under root n means 5 people. So under root 5 is 2.2367. So this comes to 34. And lower limit will be 176.67 minus 2.776 into 46.89. 46.89 is what? Standard deviation divided by under root 5, and this becomes 176.67 minus 58.21, and this becomes this one. So therefore confidence interval is 118 to 235. That means most of the data will fall between these two limits. Okay, so that's what I have presented the example today. Thank you very much for your attention, and we will now go to the second part of the lecture, that will be basically work sampling and ergonomics. Okay.